Good afternoon, everyone, and welcome to today's webinar. My name is James Lucas, and I will be the moderator for today's session. Today, we're going to be talking about the combined laser scanning and software solutions from Hexagon and PPM. These will help to support the efficient execution of industrial engineering projects. Today's webinar is being recorded and will be shared with all registrants. There will be an exit survey when leaving the webinar, so please take a moment to complete this so we can continue to improve future sessions for you. If at any point you have a question, please submit these in the questions box and we'll cover a short Q&A at the end of today. Okay, let's take a look at today's agenda. We'll start with some introductions to our speakers and then an introduction to Hexagon. Then Paul Burrows will provide a quick overview of Geosystems scanning solutions. Following this, Paul Martin is with us today to provide an overview of Hexagon PPM solutions and will share some project examples. And then we'll jump into a software demonstration. And finally, finishing with a summary and some questions. Okay, so on to today's speakers. Firstly, with us today, we have Scanning Solutions Manager Paul Burrows from Hexagon Geosystems, who many of you will be familiar with. Paul has many years' experience in laser scanning and works with enterprise customers to help the adoption of reality capture technology. Also with us today, we have Paul Martin from Hexagon PPM. Paul is the technical director with 20 years' experience with the business across various roles. Paul leads the European CAS technical team in the delivery of pre-sales, post-support training and consultancy services. Okay, so now I'm going to hand over to Paul, who's going to get started with today's content.
Good afternoon, everyone. Thank you very much for joining us again for our webinar series. And thank you for your feedback on previous sessions. So I think looking at the attendees list and looking at the registrants list this time round, there's a number of people who continue to come back time after time. So thank you for your continued support and thank you for your feedback to help shape the future of these webinar sessions. So firstly, thank you very much. And today we've got a slightly different format. We've dropped the polls due to sheer amount of content that we have. And instead of a customer today, we have Paul Martin from Hexagon PPM, who is going to talk through some really, really fascinating parts of our product portfolio on the PPM side of the business. So before we start, some of you may be familiar with the Hexagon name, the Hexagon business, but I wanted just to make sure that we set the scene correctly before we move through the presentation today and gave you some background about the different divisions within Hexagon and some of the interplay between those divisions and also the partnerships that we have between those divisions and effectively the sister company to Hexagon Geosystems. So in terms of Hexagon, it's a technical solutions provider. We create solutions which help our customers deliver projects more efficiently, more profitably, and you'll see in the different divisions in a minute how that can affect everything from manufacturing through to the PPM projects. We've got over 18,000 employees in over 50 countries, so we're a very, very strong organisation with support and sales in a large swathe of the world. We are very much R&D focused, and this is one of the most exciting parts of working for Hexagon. Is you can see here 12% of net sales are invested back into R&D, and over 3,800 employees in R&D alone. And that really does create an entrepreneurial spirit and also very much a spirit of innovation, which lends itself well to a sales organisation, sales and support organisation. We're very, very strong financially, which is why lots and lots of companies like to partner with us. We are continuing to grow and acquire companies year by year. And that strong operating margin allows us to push money back into the R&D efforts and increase the quality and innovation in our product basket. So these are some of the divisions. So we've got Hexagon Geosystems, which effectively I work for, looking after geospatial landscapes. So this is reality capture, surveying, airborne sensors and systems. We have Hexagon Manufacturing Intelligence, which looks after the manufacturing landscape. So this is part of our business that works in reverse engineering, high-end dimensional control, in everything from food manufacturing to car production. And then Hexagon PPM, which looks at the engineering landscape. So this is what Paul is going to delve into later. This is all about offshore, nuclear, agriculture, like food production, and they've got a large selection of products which lead directly into this marketplace, and Paul will introduce the solutions that will help you be productive in that environment. So in terms of the two divisions we're going to be talking about is Hexagon Geosystems. So here in particular, reality capture solutions. That's what I'm going to guide you through today. And you can see here the BLK 360, or it could be the RTC 360 or the scan station. And then Hexagon PPM, smart industrial design software to transform reality capture data into information and models. So Hexagon PPM does not sell hardware solutions, whereas Hexagon Geosystems sells hardware and software solutions. And the interplay between these two divisions is what we're going to guide you through today. But some of the markets where this technology can be deployed, one of our biggest markets and a continual growth market for us is offshore plants. The RTC 360 in particular plays well into this market because of the size and portability of the device and the sheer number of scans that you need to complete in a short space of time in order to create your 3D models, whether that's for retrofit or refit, clash analysis, or as-built scans to check that things have been installed as intended. Then oil refineries, much the same. You can see here adding into the mix of some of the as-built checking tools that we've got, and also the tank deformation tools that we have. This is just another market that we sell our solutions into, and one that PPM works in as well. On the power generation, not just nuclear, but wind and renewables, but nuclear in particular because of the remote aspect of the data collection using our tools, because it's non-contact. And we can do some cool things, including putting our products on robots and putting them into spaces they might not otherwise. But fundamentally, it's all about collecting data quickly, safely, and accurately. And this is another growth area for us, is food manufacturing. You can see, we talk about facilities management and asset management. That's where we see, digital twins being created a lot, not just in this space, across all of the previous segments that I've just covered, but in particular, food manufacturing is really moving forward with this data collection for asset management, and also minimizing shutdown time on production lines. So scanning it, having a very accurate digital twin, and then doing the redesign, or a small portion of redesign directly over that digital twin, so that it's going to fit accurately. Okay. So what is the issue with traditional reality capture? So we're talking about single point measurements, tape measure, writing down notes on pen and paper. Obviously, manually made measurements typically are inaccurate. They're by nature single point measurements, so you're not covering the whole site. Sometimes you can miss information, and sometimes the information is incomplete, and therefore you're going to have to revisit sites to make sure that you can collect more data for that particular job, which causes time, it causes impact on budget, and realistically, there's other risks. It could be anything from fire risk or explosion risk if the job is not done correctly or fitted correctly. So Paul Martin is going to revisit this slide later. These are the key constraints around a brownfield project and the challenges around completing that. Schedule, obviously, we need to make sure the job is done on time. Also, if we're shutting down an element of plant, we need to make sure we get the data collection done in a particular window, and then any refit work done in that same time frame. Budget, we can't go over budget. If we do, we have to minimize the impact of that. But if we go over schedule, we're going to impact the budget aspect. Quality, we want the best possible quality data at the point of data capture, so that we know when we're designing over the top of our point cloud that it's going to fit accurately. Any kind of data that goes to the fabricators, it's going to allow us to deliver the best possible final result. And all of that is about minimizing risk, to make sure that we don't go over budget, and we also maintain the complete safety on the plant for the contractor and the owner operator. So from my point of view, I now want to guide you through the reality capture solutions overview. So this is the field to finish story. So in the run up to this webinar, you might have seen some posts on LinkedIn and social media in terms of what we wanted to guide you through. What I wanted to do up front is tell you what you're going to see today, and make sure that you're aware of the whole story that we're going to tell, because Paul's session is particularly useful. So we're going to look at the RTC 360, the generation of point cloud data in this rich HDR 360-degree panoramic imagery. Look at processing that data in Cyclone Register 360, and some of the collaborative tools you can push out the back end, so things like TrueView Enterprise, TrueView Cloud data, or using our Jetstream viewer, viewing Jetstream data or LGS files. And the LGS files are also key to this workflow that Paul is going to talk about. So we push the LGS files across into our CADWorx solution, working in conjunction with CADWorx Plant Professional. And then on the back end of that process, we're delivering Isogen and Orthogen tools that go in, that create this package of documents and data for deliverables on the back end, which go across to the owner-operators and the contractors. So that's the story that we're going to tell today. I'm going to focus initially on the RTC aspect, and then also the software solutions as well. So talking about the whole reality capture portfolio, Leica Geosystems has got a whole range of different products, some of which you may already be using, but primarily we're going to be focusing today on the RTC 360. So on the left-hand side, we've got the handheld BLK to go, which is being released very, very soon. You've got the smallest imaging scanner in the world, the BLK 360, second one across. We've got our scan station range for survey grade accuracy and long range scanning up to 1 kilometre. We've got our ABOT AX20 UAV system and that's increasingly used in the plant environment and in brownfield sites as well to get data on a much larger scale. And also our mobile solutions. This is showing the Pegasus 2 product, which can be vehicle mounted, but we also have the Pegasus backpack. And actually, this is all about collecting data on the fly in a kinematic fashion. But all of them are generating point clouds and imagery and a rich, accurate data set, which we can then use downstream in software. So we're going to look at the RTC first. So fast, agile, precise is the tagline for the RTC 360. We think of it as a solution, the scanner itself and the software ecosystem. So you can see here on the tablet, Cyclone Field 360, which is an optional means of controlling the scanner and visualizing the scan data in the field. We'll talk about that a little bit more. So here's the scanner itself. Here is Cyclone Field 360, and soon smartphones, but we've just released the app for iOS and Android for smartphones. So that communicates wirelessly with the RTC 360 scanner. And then in the office, we have Cyclone Register 360. So there's a USB storage device in the RTC 360. We just drag and drop the data into Register 360 and start processing that data into our final colorized point cloud, our panoramic imagery, ready for use downstream. So as I said before, the tablet, the Cyclone Field 360 application is completely optional. So here you can see the user is just setting up the instrument, choosing the scan resolution, whether they want to take images or not, whether you want to use our Viz technology or not, for example, or take a double scan function as well. We can do that on the RTC 360, and you can just hit the play button on the side. Then you can piece the data together back in software if you want to, but the option is there to use it in a standalone fashion if you want to. And then we've got the option to use it with Cyclone Field 360. So this is now just going to play a short video, just showing the use of the RTC 360 by a piping designer in the environments that we're going to be talking about today.
The Leica RTC 360 laser scanner goes everywhere with it and gives me everything I need. At the touch of a button, it captures rich detail in an interactive 3D environment of imagery and measurement points. The RTC 360 works with me, following where I go and tracking in real time so that scans can be automatically registered on site. Lightweight and agile, I can work quickly across any site, capturing even hard-to-reach areas with incredible accuracy. In just 2 minutes, the scanner captures millions of points, giving me time to capture any site intricacy. And I can check, tag and annotate scans in the field using the Cyclone Field 360 app, so I don't have to spend too long in potentially dangerous areas. And I won't have to come back to recapture data. Whether at home or in the office, I can quickly upload the captured scans as the 3D model integrates seamlessly into my preferred software. With one click, I can review the data, add any further annotations, and explore the entire 3D environment.
Okay, so what you saw there is data collection using our unique Viz technology and Cyclone Field 360 app to create the pre-registration on the tablet. You then drag the data across into Reg 360, click the import button, and we can start viewing the data directly in the software. So as I said earlier on, the smartphone app is now released. So this is for iOS and Android. It's not the watered down version. This is the full version of Cyclone Field 360. So it allows you to do exactly the same: scan, view, add, check. You can take photographs and video information, add that as geotags directly into the scan data using the app. But this is going to be phenomenal from a productivity point of view. So all of our guys over the past few days have been installing this and testing out the functionality. But mobile phones, smartphones in particular, are ubiquitous. We're supporting the two biggest, the market leaders in Apple and Android, and really this allows you to get into using the product very, very quickly. So that's a fantastic innovation, and hopefully you're going to look forward to using that over the next few weeks and months. Now I just want to show this video, and this shows the power of Cyclone Field 360. So a very kind thank you to Jack Glauser from the Scan Station, very cleverly named. These guys are using the RTC 360 extensively, and you can see here this is a one-day job using low resolution scans with over 500 scan positions. So obviously a very, very long day of scanning, but you can see all of the links that have been added, and this is a screen captured directly from Cyclone Field 360, just showing the sheer size of jobs that you could handle. And that would be exactly the same experience, obviously on a slightly smaller screen, if you were using the smartphone option. So thank you to the Scan Station for that video, but this was really just to prove the point that we can handle very, very large projects using Cyclone Field 360. So onto the actual scanner itself and the hardware. 2 million points per second, so very, very fast data capture. We can collect a full panoramic HDR image in just less than a minute. So it doesn't matter whichever scan resolution you're using, the imagery is always 1 minute. 130 meter range, so for this PPM environment that we're talking about, typically that will cover most applications. Maybe if you're talking about renewables or nuclear or some external plant, maybe the Scan Station with the longer ranges might be applicable, but certainly the portability lends itself very, very well to the PPM sector. Then we have Viz. So you saw this briefly in the video from the chat, the piping engineer. This is our visual inertial system. This is a series of 5 black and white, high speed, high contrast cameras which track the movement of the scanner in real time, and then used in conjunction with IMU, GNSS, altimeter and compass built into the device, track the scanner in its environment so that we can build these pre-registrations very, very quickly on the tablet or without the tablet if necessary. Then you've got Cyclone Field 360, which we've talked about, which provides field registration. So for the geeks among us, and I'm sure there's many of us here today, are laser scanning geeks, there's a nice little animation of the internal. So it's absolutely cram-packed with amazing technology. You can see all the different flags coming up now. But in essence, you can see, we get a lot of questions about the antennas on the top. One of the antennas is a GNSS antenna, the other is the Wi-Fi antenna, and you can see highlighted the Viz cameras. So there's 5 Viz cameras providing this tracking in real time. And the next slide that I'm going to show you shows you basically this visual inertial odometry system that we use, this patented technology in Viz, which tracks the features in real time. So what you can see here is a real-time dev kit feed of the Viz cameras, and anything that is flagged green is being used as a tracking position between between your positions where you're moving to provide your delta poses between your start and your finish. And what's unique about this video is you can see here we're going from inside to out. We've got bad lighting, good lighting. We can actually use this in moonlight effectively. If it's completely pitch black with no illumination, then it's just not going to work. But in terms of the robustness of the algorithm, you can see here we are able to track some amazing features, which allows us to move between those scan positions. So that's the Viz technology. So now we're just going to look at a workflow overview. So just jumping back into this story slide that we showed you at the beginning, we're now in this portion here. Okay, before we hand over to Paul in a second. So reality capture with the RTC 360. This is just a very, very small job. And what I will make a point of saying here now is I'm not advocating not using targets for these types of jobs, but we can if we want to. We can use Viz and our registration on the tablet to do it. But with a lot of these jobs, we will typically be using a Leica total station to fire in control points on spheres or black and white targets to tie this to an existing control network and also provide repeatability and redundancy. So you can do that process all in software if you need to. And so I'm not, what I wanted to highlight here is that absolutely we can use a targeting-based method. But you can see here we've got some little waypoints, there's little grey waypoint flags in this data as it's rotating round. They are the assets. So you saw again in the video, the guy with Cyclone Field 360 is able to tag those assets in the field, and they follow down all the way downstream through our processing into our true spaces in CloudWorks, into our LGES files, into Jetstream Viewer, into our True Views. So they now become ubiquitous throughout the whole process. So adding value to the full digital twin creation, asset management, facilities management tools. And at the end of Paul's presentation, we'll talk about how that all comes together to be able to provide one cohesive picture of the site. So here's the panoramic image. This is just taken directly out of Jetstream Viewer. You can see we've got these little cheese heads. We've actually got some changes to the icons coming up shortly in future releases. But essentially all I'm doing is just jumping through these panoramic images using the Jetstream Viewer. And these are 200 megapixel. We can export them directly out of Register or Register 360 as well if we want to. But really I just wanted to show you this video to highlight the quality and resolution of those images, which act as a really nice deliverable in themselves, but also if you've got someone who's modeling data, they can use this as an additional tool to make sure that they're modeling things correctly and they've got a reference point to refer to. And these images can also be viewed and pulled up in TrueSpace in CloudWorks, for example. So this is the data preparation stage. So this is using Cyclone Register 360. We're just going to create a new project, and then we use the drag-drop methodology. We've got the project file there. We're just going to drag it over there. It says drag files here. That will then start to load what we call the lightweight preview object. So these are similar to the same objects you see in Cyclone Field 360. And you can see those viz links that have been created. So those links that have been verified on Cyclone Field 360 already present. And now over the next sort of 10, 15 seconds or so, you'll see these lightweight preview objects load in, and we'll gradually bulk up this data set. What we do here is we're just doing an initial review to check that the data is as is. You might have multiple bundles. You might have jobs from jobs from a couple of different days. But ultimately, once we're happy, we can just go down to the right-hand corner, as you saw the guy doing the video. We click import, and that'll begin the process. And you can see on the right-hand side as well, we've got the ability to extract targets. We can do an auto cloud registration if we haven't got the viz links. Or we can say that the data is pre-registered if it's coming from another data source. So that is Cyclone Register 360. Paul is going to focus on this aspect. So this is step 3. This is the modeling aspect. And what you can see here is using our CloudWorks tool, sat within either BricsCAD or within AutoCAD, interfacing with the CADWorx Plant Professional tool from Hexagon PPM in order for you to redesign or design on top of the existing point cloud data. So I'm not going to labour this point. Paul is going to do a fantastic job with the software aspect to show you how this process works. But in terms of the collaborative tools that I talked about from the back end of Reg 360, one is TrueView Enterprise. So TrueView Enterprise or TrueView Cloud is completely browser independent viewer and operating system independent. There's no plugins into your browsers required. You can run this on your own server using TrueView Enterprise, or you can use TrueView Cloud, which is on a Leica server, which is like a paid-for hosted service. But what I'm going to do now is just very, very quickly fire up a link. If I just click this link, I just need to pull the window across from my other screen. So I'll just drop it here. Okay, and I'm just going to go down to one of these other projects. So if I go to, I was talking about integrating models. Here's a nice one here. It's quite an old data set, but it was just to highlight the fact that you can have scan data and the model information directly within TrueView Enterprise. So I'm just going to jump into a scan location. You can see now, if I just zoom out a bit, you can see the model information and some areas where that haven't been modeled, you've still got the scan data. And we can jump between any of those scan stations at will, and we can start seeing. So this is just, you can see all the grayscale areas and those black and white targets that I mentioned for control as well, and then the model sitting directly on top. So if you can get the model in using our Cyclone Object Exchange format, then you can push it out alongside when publishing out your TrueView, and you can see that there. Now, what I want to do now is another example, which is this plant example here, which is quite nice. And the reason here is I want to show you the geotags. So same type of environment. So here you can see this really nice, rich photography, HDR photographer from the RCC 360, and you can jump between the positions. But here, those geotags that have been collected with Cyclone Field 360, I can just double click on any one of these, or click on one of these, and it will open up the associated asset information. And that could be, it could be a video file, could be an audio file, could be a document, a PDF. But this now sits in this tool. And you can take measurements in here. You can add markups and snapshots. You can change and view different layers. So you can view the grayscale layer if you want to, or you could view the intensity layer, for example. So it's a very, very fully featured tool. But it's what I call 2.5D. You can't view the full point cloud. So I'm just going to minimize that and get back into our presentation. Okay. So this is Jetstream Viewer. So Jetstream Viewer is a free of charge tool. There's no install required if you don't want to. You can install it, but there's also a Jetstream Viewer portable solution which will run directly off a USB stick. And this will read data hosted on a Jetstream server, or it will read our LGS file format, which we're going to hand across to Paul to deal with in CADWorx and CloudWorks. But you can fly through the point cloud, you can jump to the scan positions, you can take measurements, you can use clip boxes. In fact, if you've created any clip boxes in Register 360, they will be honored and brought through as part of the LGS file. You can also do markups. So some of the markup tools that you can use in TrueView, you can now use in Jetstream Viewer as well. So this is something that you can hand over to the client. You can give them the LGS file or access to the LGS project file, the Jetstream project file, and they can just jump around the point cloud. So this adds the full 3D element as opposed to the 2.5D aspect of TrueView. But you can see the interfaces are very, very similar. We've got these, what we call the cheese heads, the yellow triangles we can jump to, and we can really, really, really get to grips with the data and use this as an additional tool to make sure we're designing as we should, and we can check certain objects in there. And you can see here we're now just doing some measuring directly on the point cloud. So it's a really, really nice, lightweight tool that you can share with your customers. So I just need to like this. Okay, so now we're moving to what we call the handshake phase. So we're pushing out the LGS file from Cyclone Register 360, and that LGS file can be consumed in our CloudWorks products. So that's across a whole range of different solutions such as Revit, Navisworks, BricsCAD, AutoCAD. But in particular, what we're going to look at in this next phase is using CloudWorks in conjunction with CADWorx Plant Professional from Hexagon PPM in BricsCAD and also AutoCAD. So back to our story slide where we are right now is Paul is going to take over, Paul Martin from Hexagon PPM, and he's going to take you through this part of the journey so we can get to the end looking at the documents and data, and also then the final stage of this is how we can package up all these documents and data, 3D models and TrueView content into some really nice solutions. So Paul, I'll hand over to you, and I hope you enjoyed that first section, and I'm sure you're going to get an awful lot from this next section from Paul Martin.
Thank you very much, Paul, and thanks, James, for the earlier introduction. Hello, everybody. It's a pleasure of mine to be here today. We're going to first of all look at a short introduction to the Hexagon PPM solutions, to our portfolio of software solutions that span the whole project and plant lifecycle. These are used to execute both greenfield, new build projects, and of course brownfield maintenance or plant upgrade type projects. The 3D design and visualization solutions highlighted in yellow in the second column from the left, these all work with CloudWorks. First of all, a little bit more information about the three solutions that you see here on the screen that are in that 3D design and visualization set of products, or the products portfolio. First of all, Smart 3D on the left of the screen there. This is Hexagon PPM's premier next generation data-centric and rule-driven plant design solution. Smart 3D uses the CloudWorks for Intergraph Smart 3D plugin for efficiently manipulating as-built point cloud data coming from laser scanners with Smart 3D, and it's all about, of course, aiding better retrofit design, construction, and operations. Smart Review in the middle, it's a complete visualization environment for interactively reviewing and analyzing large, complex 3D models of process and power plants. This software provides all the visualization tools needed to review designs during engineering, construction, or maintenance. Point clouds are incorporated with 3D models using the CADWorx for Smart Review plugin. And this powerful combination enables designers and engineers to perform a plant walkdown without leaving the comfort and safety of their office. Now today we're actually going to focus on CADWorx, which is an economical DWG-based plant design system, which although doesn't have a plugin of its own, it also works with CADWorx. Now CADWorx is actually a comprehensive suite of products supporting process design, plant design, design review, and automated generation of deliverables in support of the execution of the greenfield or brownfield plant design project. CADWorx plant and CADWorx structure are used to create the multidiscipline 3D design models, and as you can see here, both can work in conjunction with CADWorx. A little bit about CADWorx first of all. CADWorx Plant Professional, it's a fully featured 3D plant design solution. As you see here, it's got many capabilities that you typically find in a plant design solution for this sort of task. It does include a complete range of tools for efficient 3D plant design. It's very easy to learn and use, and has helped thousands of companies worldwide to create the revenue earning deliverables quickly and efficiently. CADWorx Structure Professional, this is the newest member of the CADWorx design suite. It provides features that help structural designers design both structural steelwork and civil structures formed from precast or formed in place reinforced concrete. Now you're probably wondering, how does CADWorx work with CADWorx if no plugin actually exists? Well, it's because all of the solutions in the CADWorx design suite work either with AutoCAD or BricsCAD as their CAD platform. In fact, CAD models in DWG format produced on either platform are fully interchangeable, which not only provides flexibility in how you can work, but also an opportunity to reduce license costs if some or all of the AutoCAD seats are replaced by BricsCAD seats. And as you know, CADWorx also works with AutoCAD, but it also now works with BricsCAD and has done since last year, since the CADWorx for BricsCAD release was first released. And this means, of course, that both CADWorx and CADWorx can both coexist side by side on either CAD platform. So this combination, what it does, it provides a powerful solution for the efficient and economical execution of brownfield projects, providing everything required to design and document the changes to be made to the brownfield plant. So how does this combination help you meet the challenges of brownfield projects, which Paul mentioned earlier on, which of course, like any project, require you to deliver on schedule and budget whilst delivering higher quality, and all the while, as the project evolves, trying to mitigate risk. It's because this combination supports economical and fast-track project execution. During the detailed design phase, intelligent, accurate, specification-based plant design models can be quickly and easily developed from or against point clouds. If the change requires analysis of the design to applicable design codes, time and cost savings due to the ability to bidirectionally exchange design information with analysis and vice versa are possible. Specification-based plant design models ensure accurate bills of materials or material takeoffs generated from the 3D design to support accurate, timely, and economical procurement of the materials. When the virtual design has to be turned into physical reality, error-free fabrication and trouble-free erection or installation of the steelwork, piping equipment that are going to be installed to effect the change to the plant, this is all possible due to the high quality and high accuracy deliverables being produced from the 3D model. And post-construction, when the plant is operational again, a high-quality digital information handover consisting of both data and documentation can be delivered to the client, supporting not only operations and maintenance tasks, but also digitalization of the plant asset. But of course, don't take my word for it. Here's what some of our existing customers say. So first of all, here's Mercury, a European contractor based in Ireland. This job was actually done in the Netherlands. The scope, as you see here, was to design a new process plant with product pipelines that needed to connect into the existing facility. To achieve this, it was necessary to route the new pipelines along an existing pipe bridge and across the roof of the existing structure and into a new building. Now, the goal of the project was to shorten the project schedule by maximising the amount of piping prefabrication that could be completed off-site before piping installation was performed on-site. The problem, of course, was that there was a lack of accurate as-built information, and they had to capture the existing conditions quickly and accurately, of course, to support their goal. The solution was to use laser scanning to capture the as-built situation as a highly accurate point cloud, and then to use CADWorx to design the new plant. And of course, this company was very familiar with CADWorx, having used it extensively on other projects for a number of years. So they used CADWorx, Plant Professional, and Isogen together to deliver the benefits that they were looking for. And as it shows, as shown here, Kieran McCreary, the 3D VC BIM engineer, says that they were able to produce their isometrics immediately after completing our coordination process, and that led to them, having more certainty in the schedule due to being able to track progress better. They did do scans as the job progressed, and of course that enabled them to use that updated scan data based on what was being constructed as construction went on, to adjust the design so that they ended up with very accurate deliverables that allowed them to meet their goal. So they were able to reduce the labor on site due to the ability of being able to use that combination of laser scanning to adjust and fine-tune the design as the project progressed, and of course produce very accurate, high-quality deliverables from the CADWorx solution. Here we have the Badger Company, a company that's based in both the Netherlands and Romania. Their project involved investigating the possibility of demolishing an existing plant that you see here up in the top right, to see if a new plant could be built on the same brownfield site. They needed to install some further major equipment items and a reactor, and of course the challenge was that there was no accurate information about this facility. I think the most they had was some kind of Google Earth view of the plant as a sort of document. So they also needed to capture the as-built situation very quickly and accurately, and they wanted to use that information that they captured using a laser scanner in the form of a point cloud in CADWorx, so that they could, of course, create the plot plan that you see here on the screen. So they used, again, laser scanning hardware in combination with Cyclone for the point cloud registration. TrueView used to obviously interact with the project stakeholders and to make decisions, and CADWorx Plant Professional to create the model that you see in the bottom right of the screen here, which didn't, of course, have to be overly complicated. Just needed this overall layout of the major equipment items to create the plot plan that you see here. Of course, they saw immediate time savings because they weren't doing a manual survey. They were using laser scanning, and of course that fed into the CADWorx solution. Using the modeling here, they were able to obviously create this model very quickly. And the fact that CADWorx, as you know now, is a DWG-based application, that meant, because the designers working on the project already understood AutoCAD, that they were able to start work very, very quickly. And finally, here's SBCTech, an engineering contractor in Italy, who only recently invested in the RTC 360 scanner, which of course is using Cyclone Field for the on-site registration. Here's the refinery. So this is a refinery project in Jetstream Viewer, and here's the CADWorx model visualized in conjunction with the point cloud. And here's the finished sort of results of the new piping and equipment superimposed inside the point cloud. And the scope and goal for this project was that they needed to design and install some replacement equipment and piping into this existing refinery. It was a sort of debottlenecking or an improvement of the process that needed to occur by introducing this new piping and equipment. And as I said, the technology was fairly new to them, but they wanted to evaluate, how the use of modern solutions would affect the project man hours. Could they reduce it? Could they work more efficiently and more productively? As I mentioned, the challenge was and always is to install new equipment into an existing facility. There's always the potential for clashes, and in this case, some of the equipment that was being installed was bigger, so there was certainly the chance of clashes. They used quite a lot of the combined Hexagon Geosystems and Hexagon PPM solutions, as you can see here. They also had to do some stress analysis of some of the piping that you see modelled on the left. In the Caesar 2 stress analysis solution. But what they found, of course, that they had a very easy to use overall solution due to the user friendliness of the hardware and, of course, the software that they were using to create the modeling, the CADWorx solution. That enabled them to increase their ability around estimation of project costs. And of course, the reliable deliverables from the system gave them high quality information to affect the physical change to the plant eventually. And Luca Gaetano here, the commercial manager, says that this smart project approach, they plan to make it a company standard in the future. So obviously a very good example of how the Hexagon Geosystems hardware, software, and the Hexagon PPM software work very, very well together. Okay, so let's take a closer look now at how CloudWorks and CADWorx are actually used together to execute the typical stages of a brownfield project shown here, which starts with reality capture and ends with the handover of data and documents to the plant owner-operator. Now, at this stage, we've already set up the CADWorx project environment. We've taken delivery of the reality capture data from the supplier or from our own scanning team if it's done in-house, and we're ready to start using the point cloud data to design the changes that we're going to make to the plant. Now, how we use the software, of course, depends on the project scope. Now, if it's a plant upgrade, for example, the retrofit installation of piping, equipment, structure, etc., into an existing facility, creating optimal routes and layouts is easily achieved, and problems during construction are avoided using this combination. Clash detection offered in both solutions enables collision-free designs to be easily and rapidly developed against and through the point cloud. Furthermore, without having to delete and remodel, saving a lot of time and effort, CADWorx Plant Professional's powerful pipe routing, design modification tools, and self-aware component behavior enables clashes with the point cloud during design to be easily rectified with minimal effort. If it's an as-built model that's required to support plant maintenance, for example, the repair and replacement of corroded piping and other plant items, this will often require an accurate reproduction of what already exists to be created. Fully intelligent as-built CADWorx models can be quickly and easily developed on top of the point cloud. CloudWorks shape-fitting tools provide size, centerline, and directional data for piping, equipment, and steelwork to be modeled, from which accurate deliverables for fabrication and construction can be quickly and easily produced. So first, let's take a look at using CloudWorks and CADWorx for plant maintenance projects. So we're now at this point in the project execution workflow. But first, one of the key features of CADWorx Plant Professional is that it includes several piping rules that help speed up design by helping you to work faster and smarter. These rules help to prevent errors and ensure higher quality designs are produced more easily and with less effort. You'll see examples in the movies that follow. So here we're going to look at how we can model a pipe. So we're connecting to the LGS file or the point cloud, and we're using TrueSpace just to very quickly pick a station in the area of interest. So here's TrueSpace on the left, and we've got the CAD package on the right. We use the quick limit box to isolate a 5 meter cube volume of point cloud, and this is the focus of the modeling exercise. Put it in an ISO view, zoom into the pipe of interest, and now we're going to use the pipe fitting tool to find the size, centerline, and direction of the pipe that we want to model as an intelligent pipe. So we just click on the point cloud, and we build up a series of individual segments. Down here, we can use the fence option, select all those points, and we get an accurate fit on that small stubby section of pipe. Do it here, not so accurate, but the center line is what we're interested in at that point because it's actually an expansion component. So we turn the point cloud off, connect all the individual sections of pipe, and this effectively gives us the full center line of the pipeline. So now, in the same environment, we switch from CloudWorks to CADWorx. Just orientate the view. You can see we've got a 60 outside diameter, 50 nominal inside. Pick that size in the CADWorx spec. Here's all the components in the spec, and we now just start to quickly, easily, using that center line, create an accurate pipe, an intelligent CADWorx pipe. Now down here, we've got a change in size. So we've got a concentric reducer. Again, we just change the size. Pick the concentric reducer from the spec again. And just put the point cloud back on first. So here's the concentric reducer. Zoom into the end of the center line. There's the component. We've got a fitting to fitting situation here, so we just need to attach the weld neck onto the concentric reducer. Zoom in, and you can see there's an accurate fit of that flange, making the connection with the pump. At this end, what we've actually got is a nozzle on the vertical piece of equipment and a flange connecting to that nozzle. But what we're going to do is use the flange fitting tool to accurately find, with just a point selection on the point cloud, the flange face. And now we're going to place a weld neck flange. Now you can see we're only placing a single flange at the moment, but because of the piping rules, what we're actually going to get is a pair of flanges appearing when we make our final click. There we go. So we save time by not having to place two flanges in a gasket. We just did it all in one action, very quick and very efficient. So the piece of pipe after the second flange nearest to the vessel, well, that's not actually pipe. That's, as I said, a nozzle coming off the equipment. So what we're going to do is we're going to make that flange a connection reference, just give it a tag, and set it to existing so that we don't see that material on the isometric later. So there's our final connection. Now in CADWorx, we can use these grips, these plus grips, to pop out the component list. And again, we're picking the valve from the spec, single point click on the cloud, and you can see again that the flanges and gaskets associated with that valve come in because that rule allows us to place those automatically. So very quick, very efficient, and there we have our accurate as-built pipe. And of course, if we wanted to rip out the existing pipe and replace it, we can take that model now, turn it into a deliverable, and then be assured that what we fabricate will actually connect up when we construct it. Now here we've got an example of using the same tools, but this time we're going to model some equipment. Now we use the cylinder option, and we've got realistic set on at the moment. So we switch it to wireframe, and you can see that the shell of the vessel actually goes beyond where it really starts, which is at that weld line where the dished end is. Now in CADWorx, we build equipment with an internal CADWorx equipment module. So we're giving the vessel a name now. And we're going to specify the start of the vessel shell just by using the information that we get from that cylinder. So that cylinder is sort of a construction aid. There's the size of the vessel shell. So we type that in. So we've now got it perfectly sitting on top of the shape that we fitted earlier, the cylinder that we fitted earlier. And now we can build up the actual vessel by just adding the child component onto the vessel shell. So in other words, the dishes and the nozzles and so forth. So we just flip one of them so that it's at the other end of the cylinder. And we delete the original cylinder that we used to just find the center of that vessel. And as you can see, we've used that to construct an accurate vessel shell and dish ends. And you'd continue now from this point on to add the nozzles on the top, any nozzles on the side, using the shape fitting tools, and of course the same with the structural supports as well. In the case of steel, we're going to use the steel fitting tools, and as you know, CloudWorx has this steel library within it, so we just picked a European size, pick 2 points. The system finds the size, so initially it places the CloudWorx steel member, but what we want is a CADWorx steel member, so we just use that again as a construction aid just to place the same element, the same structural section, but this time as a true CADWorx structure object. So we're just going to click on the corner to place it, stretch it up to roughly the same length, or just use the end of the CloudWorks element, and then flip the view around. And of course, using a point snap, we can just click on the end of the CADWorx structure model, pull it down to the right elevation at the bottom, and the same at the top, so that it actually supports the saddle of this piece of equipment above. And if we want, we can continue to add other structural members. So CADWorx structure, as you can see, supports columns, plates, all the various structural components, I-beams and channels and so on that you typically find in any kind of industrial plant structure. So there's the base plate on the bottom of the CADWorx structure there. So as you can see, what we've got here is more of the model developed and superimposed on the point cloud. And of course, this would be ideal now to use if there wasn't any plant documentation available and you wanted to create that. You could now use your standard CAD techniques to create that kind of documentation. So this is the end result. What you get is a fully intelligent, specification-based, as-built model, or an as-built design basis, as it's often referred to, from which high-quality, accurate deliverables can be produced, or on which new design work can be based in the case of a plant upgrade. The model also supports, as I said, the creation of documentation when there is none. So next, let's take a look at using CloudWorks and CADWorx for plant upgrade projects. So here's an existing point cloud and the 3D as-built model created from it. So this is sort of the before situation, so the start of the project. You can see the two red circles. This is the area of interest. We're going to introduce something new. So for this plant upgrade project, new equipment and new piping are going to be retrofitted as shown into the existing facility. And to avoid problems during construction, the overall pipe routing, which will be via the pipe rack, and the tie-in to be made to the existing vessel, need to be made clash-free, of course. The line that we're going to model being a high temperature and high pressure line, the final pipe design also needs to be stress analyzed to ensure it is safe and compliant with applicable design codes. And before we look at an example of that, to help in this kind of task, CADWorx Plant Professional provides a number of productivity tools that speed up design and help you to make design revisions more easily, saving not only time, but avoiding unnecessary remodeling and rework. The self-aware components behavior that you see in the bottom left, this is where the components inherit the property of the attached pipe. Components can be rotated around an axis, and you can even move the entire pipeline, and all the connections will go with it. So very useful to make minor tweaks and adjustments to the routing without having to remodel again. In the bottom right, the auto routing capability, this allows you to route between 2 points and choose the best design. This saves time and optimizes designs by routing pipes automatically. And of course, all of these capabilities are all about making design more efficient and increasing the designer productivity. So here's an example of that. So what we have is the pump and the vessel already in situ inside the point cloud, and we want to route a new line. We've already assessed the point cloud, made some decisions where there is space, put some nodes into the environment that we can connect to. And of course, what we want to do is to route this new pipe along this pipe rack so that it's supported sufficiently, and do so that it doesn't clash, and make sure that the pipe, of course, sits on the top of steel. So we just click on there, and we start routing off into the distance. Now we have to rotate, and perhaps we want to change the view so that we see the color intensity. And the pipe at this end also needs to change in elevation so that it sits in the space next to the walkway here on this pipe rack. So we just use a node again to help with that. Moving along, and we're going to switch the view around, because what we want to do now is make that final connection. As I said, we can use auto routing to do this. So we've already added some components to the nozzle on the vessel, as you can see. So we've got a flange, and then we've got a 45-degree elbow. So we use the connect option, and you can see the lines represent the various routes that we can take. We actually want this one, so we just click through them. All done. No need to finish that off by modeling. And of course, the final stage is to check that the routing certainly doesn't clash by doing visual checks. And beyond this, we would want to, of course, do the clash detection between this model and with the point cloud to be absolutely sure that we're not going to see any clashes when we come to erecting this pipeline in the plant. So with the design finished, the next step is to perform engineering analysis to ensure the designed items, piping, equipment and structure are safe and code compliant. Whether existing piping is being replaced or new pipework is being installed, if it's part of or will tie into a high pressure, high temperature system, to ensure a safe design is produced, piping usually needs to be stress analysed. Now we offer Caesar 2, a pipe stress analysis solution to do this. And similarly, for the analysis of pressure equipment, we offer PV Elite and Visual Vessel Design. For the analysis of steel structures, GT Strudel, and for the analysis of storage tanks, Tank. You can find more information on our website if you wish to visit the link at the bottom of the screen. Now, time is saved and errors due to remodeling are avoided because piping designs can be transferred bidirectionally between CADWorx and Caesar 2, as shown here. And here's a very quick example of that. So here's the piping CADWorx. Now in Caesar 2, we've added some supports, we set up the boundary conditions, and then we run the analysis. And providing we don't get any red warnings on the load cases analyzed section of the report here in the top left of the screen, then the pipe has passed code checks. Now, of course, there's significantly more to this software, but for today, that just gives you a little flavor of what it can do in support of these projects. Now, once the design is considered code compliant and no further changes are envisaged, final documentation can be produced for fabrication and construction. At this point, the virtual design is going to be turned into physical reality. So you really want to be sure that the deliverables you're going to produce are complete, accurate, and easily understood. Because if delays occur due to dimensional inaccuracies or omissions, costs can significantly increase if rework or scrappage occurs whilst errors are being rectified. Fortunately, Isogen, which is owned by Hexagon PPM and which is the industry standard for automatic generation of isometric drawings from 3D models, is included out of the box with CADWorx. Isogen produces not only complete pipeline isometrics for construction, but can also output spool isometrics for pipe fabrication, and all at the click of a button. So here is Isogen in action. So we run Isogen, pick the pipeline, generates one or more sheets, just one sheet in this case. We open up that plot file, which itself is a DWG file. There was a connection to the pump. Here's the connection to the vertical vessel. And you can see that what we've got on this drawing is a list of the fabrication materials, a list of the erection materials needed by the construction team. We can have a cutting list on here as well as a welding list shown in the bottom corner. And of course, this configuration of output can be completely configured to your company standards if required. Now, as well as using Isogen, you also have the option to use Orthogen, which is an add-on for CADWorx. This solution is used to produce industry standard 2D layouts and orthographic drawings, which are automatically annotated by the software. Of course, these deliverables are used in the construction activity. And Orthogen not only produces 2D orthos, but annotations can also be included in 3D views too, as shown here. So, I'm sure you can appreciate that the drawing on the right of the screen, which shows a pipe rack, of course, pipe racks tend to be pretty congested, and it's not always easy to know which pipe is which. Then this is going to help the construction team to understand exactly the arrangement of the lines, and how the construction needs to occur if they're starting with just the steel structure and nothing else. Orthographics can also include point clouds as shown here, which of course is useful if clashes are to be avoided during construction when space is tight, and also are useful in the event there are any kind of discrepancies in terms of the positions of items post-construction when piping is being hooked up. So here's just a quick example of Orthogen. So we've taken that same model, we created a viewport, we launch Orthogen inside CADWorx, and in Orthogen you can add layers of annotation. So the first time we're going to add the tags just to the vessels, you can see them just appear there, and then the second time we run it, we're adding the pipeline references and the various dimensions and any other annotations. The system comes with 40 pre-configured styles out of the box for the various disciplines, for equipment, structure, and piping, of course. And you can create your own user-defined styles if you wish. So it saves a lot of time and effort in obviously creating this kind of deliverable manually. Clearly, this is not a very detailed one, but of course, some drawings can be very, very detailed, very comprehensive, and of course, take a lot of man hours to actually do the manual addition of all this kind of annotation, whereas Autogen will do it in a matter of seconds. So the final stage in the project is usually to validate that the upgraded facility post-construction accurately reflects the design documentation. And if it doesn't, to raise the design, the model and the deliverables extracted from it to as-built status. These then become the final set of deliverables handed over to the client, which are then used to operate and maintain the facility and help the plant owner operator demonstrate regulatory compliance. Now, CADWorx produces complete digital information, and as such, what it produces supports plant owner operators in their mission to digitize these facilities, or their facility. So that digital information for their asset, whatever it may be, can benefit the plant personnel working on the plant in their day-to-day work. And just to bring the whole story together, I'm going to hand back to Paul now to show you an example of this in our other solutions.
Thank you very much, Paul. So, yeah, just to wrap that up, as I think the key point Paul said there is we're handing over a complete digital representation of the site. And you can see here, what we're going to show you here, this is using our TrueView SDK. So we have an SDK for TrueView which allows other partners and other parts of our business to utilize the TrueView platform and embed it within their solution. So this here is the Hexagon Smart Digital Asset tool. So this is for the collaboration. I'm going to run the video now. So this effectively could be a tablet-based or browser-based interface. But what we can do is we can drill down to an individual tag within a particular job, a geotag. We can then see all the associated information around that tag. So you can see here we've got mechanical information, we've got procurement information, maintenance information. But in particular, because we're now using the TrueView SDK, we can jump directly to the scan where that geotag is referenced, and then we can visualize the scan data. So this can all be done from, like I say, a simple tablet or browser-based interface, but it's then just a very nice tool to get this data into as many people's hands as possible across the projects, across multiple projects. And what's brilliant about the TrueView SDK is we've already integrated it into Hexagon Smart Build. We've integrated it into the Multivista platform. So Multivista is a construction documentation company that Hexagon also owns. But you can see here the final stage of this is we can jump and see the other, the ISOs and the orthographics that have been generated as part of the Hexagon PPM portfolio. So just to go and close this whole story off, as we said, going back to the slide that we showed at the beginning, we've run through the reality capture aspect using the RCC 360, producing our rich point clouds, which can then be displayed, all the points all the time using our Jetstream or LGS technology. And we've got the imagery, which can be used as reference or draped across the point cloud as well. Process that data in Reg 360 to create other deliverables such as the collaborative tools TrueView Enterprise. We showed you the live demo, and also Jetstream Viewer, this free of charge viewer to hook into Jetstream Enterprise data or the LGS files. And then importantly, that digital handshake over to the Hexagon PPM solutions and also CADWorx with the LGS file. So, Paul, if you just want to wrap up with some closing comments from your side.
Yep. So hopefully you've seen what is a very easy to use, straightforward approach for creating as-built models in support of brownfield projects. What we're presenting here is a very powerful and easy way to use reality capture data to support the efficient, economical and successful execution of any brownfield project, and for any industry, certainly all of those industries that Paul featured earlier on, amongst many others. And of course, the end deliverables that you get out of the system are very high quality, and as Paul just explained, this package of information, models, reality capture data, all feeds over to the client to utilize in the plant life cycle. So with that, thank you very much. Would you have any questions?
Yeah, I think, well, we've got a list of questions here, so thank you for everyone that has responded. We've got a short amount of time now that we can answer some of those. So there's a question from Krista, who says, can you work with CADWorx, with CloudWorks and Jetstream Enterprise? And that is a solid yes, Krista. Yeah. So that's what we've demonstrated today. So CADWorx is a plugin sitting on top of BricsCAD or AutoCAD. CloudWorx is our suite of plugins for, as I said, a whole range of CAD products, and Jetstream Enterprise is our server solution. What we are seeing, which is quite interesting, is Jetstream Enterprise primarily is run off a local server, but there are customers now who are investigating deploying this on a web server and actually allowing Jetstream files to be accessed remotely across businesses, across continents, or whatever, across a region or between offices. So that is something that's happening, and the benefit of Jetstream now as well, or added benefit of Jetstream, we've got password control on given projects, so you can lock that down to a select series of users, and you'll see over time the user access control and the permissions on the way we deploy Jetstream Enterprise will improve for these types of projects. But yeah, that's a solid yes to your question, Krista. There's another question from Vasily. I hope that I've pronounced that correctly. How will CADWorx work with a team of multiple users, 10, 20, 30 users in the same environment? So I can answer my side, Paul, and I'll let you answer your side. My side, in terms of if you've got Jetstream data that is being read into the CloudWorx application, then you can scale it massively. You can have 10, 20, 30 users. It doesn't matter. There'll be no impact to the speed of loading the point cloud. From your side, I imagine you just need multiple licenses, but maybe there's an aspect of the modeling that needs to be addressed.
Yeah, I mean, obviously there's a significant number of users there, but CADWorx is, a design file-based solution. Whether it's working on AutoCAD or on BricsCAD, what typically is happening is that designers are working with reference files, but as those reference files change, then of course notifications are sent to the other users that are utilizing those same design files. So they know when changes occur, and then they can of course take account of those changes. So that's typically the way that you would work with CADWorx on a project. And of course we have many customers that work in that way and work very efficiently in that way with obviously IT support and management. Okay,
so the question here, how do you get data from Register 360 into CloudWorx? So currently we can use LGS files or Jetstream data. There is another means as well where you can export an E57 and use Cyclone to read that into a model space. But yeah, that's to Sanam. So thank you very much for that question. And there is can you send some links to demo projects or point clouds in a web browser? Right. Okay. Yeah. So there was a question earlier about whether we have a solution for providing point clouds in a web browser. So currently, no. What we do have is Jetstream, which can be run, as I said, locally or over a network. So we have got a number of people who are using that. However, there is interest in running point clouds in browsers. There's a number of off-the-shelf solutions from various people available. There's also a question here about using data from other solutions, so other third-party scanning solutions, in particular reference to FLS files. So yes, you can import FLS files directly into Register 360. You can push those through into Jetstream and LGS, and you can then use that data alongside the CADWorx platform. So we try and be as open as possible in terms of the infrastructure, and we also support import and export of recap files as well, so that you can use those alongside. So there's lots of different ways that you can get the data. I think if we can scroll up just very quickly, James, I think that's probably all of them, isn't it? Actually, yeah, that's most of the questions. If there's any that we've missed, then we will contact you directly. So thank you very much for everyone who's participated today. We will, as we said before, there was one question. Will there be a recording? Yes, there will be a recording, and we'll send that to you probably within 24 hours. So you can share that with people, and anyone who's not attended obviously will get a link to view that. If you've missed some of the content today, if you arrived late, and we've noticed the numbers changing throughout the course of the presentation, then you can of course catch up at your leisure. But please, when you exit the webinar today, please make sure, as James said, you fill in the questionnaire. It really does help us change change and shape the future webinar series. I firstly, and before we close, I'd like to extend my thanks to Paul Martin from Hexagon PPM, who I think put on a fantastic presentation for you guys today. We've done something slightly different in terms of not including a customer, but we wanted to show you, our joint approach to this market from the right through from the reality capture through to the end deliverables, that field to finish story. So thank you, Paul, and once again, thank you to James Lucas, who makes all the magic happen in terms of organising it, getting the website ready and the registration pages ready for you to all join the event. So we'll see you next time. If there's any further questions, please let us know, and we'll be in touch soon. Thank you very much.
Thank you.